Welcome to the Getting Started tutorial of VirtualLab. After going through the tutorial, your first contact with VirtualLab Fusion, you should have heard about the concept of light path diagram. In this session, we'd like to show how to build up a simple optical system in the light path diagram. We will guide you through this process step by step. To create a new light path diagram, you may click on the new icon and select Light Path Diagram, or click on the Starter Toolbox icon. A light path diagram consists of two paths, a light path view and a corresponding light path editor. Let's come back to the light path view, and here we will build up a focusing system as an example. In the panel on the left, there's a list of light path elements, including light sources, components, detectors and analyzers. To build up a system in VirtualLab, you just need to select the right light path element and connect them properly. Starting with the source, we would like to choose a plane wave. Use your mouse to select the plane wave. Drag it into the working area on the right, and release it at the position you want it. The plane wave is to be focused by a spherical lens, which can be found in Components. We place the spherical lens behind the plane wave source. To make the system complete, a detector is needed. For that purpose, we add a virtual screen at last. The next step is to connect the light path elements. There are different ways to do. What I would like to show is a straightforward method. Click on the small triangle icon on the plane wave source. Drag it towards the spherical lens. Then, the connection is simply done. In a similar way, we connect the spherical lens with the virtual screen. The parameters of the optical system must be set properly. You may find more details on settings of sources, components, detectors, and analyzers in the related tutorials. While in this session, we will only go through the system briefly. Double-click the plane wave. Its edit window pops up. Go to Basic Parameter Type. We adjust its diameter to 12 mm times 12 mm. The spherical lens should be placed at a certain distance behind the source. Click on the coordinates below it. Set the Z coordinate to 50 mm. Then, double-click on the spherical lens. Amongst various information, we found that it has a focal length of 100 mm. To examine the system performance in the focal region, we set the virtual screen at 100 mm behind the lens. Now it is time to run the simulation. We recommend to always start with the ray tracing system analyzer for the investigation of the system. Double-click on the ray tracing system analyzer. Because our system is rotational symmetric, it is better to change the ray selection method from XY grid to hexapolar. Finally, let's switch to the light path editor and select Ray Tracing System Analyzer as a current simulation engine. Then press the Go button. You may now examine the system as you like. If you have any questions, please don't hesitate to contact us.